ChatGPT feels like magic, but under the hood, it's built on some fascinating systems. Today, we'll break it down in plain terms. Understanding how ChatGPT works helps you get better answers, build better apps, and think more critically about AI. ChatGPT isn't conscious. It doesn't search the web. It's just incredibly good at predicting the next word. ChatGPT is a chat interface built on top of large language models, especially the GPT family, like GPT 3.5 and GPT 4. LLMs are trained to predict the next word in a sentence, one token at a time. That's it, but scale makes it powerful. ChatGPT doesn't see text. It sees tokens, which are then converted to numbers, chunks of text converted into numbers. Every word, emoji, even punctuation. GPT models are trained on vast swaths of the internet, books, code, Wikipedia forums, to learn language patterns. What is GPT anyway? GPT stands for Generative Pre-trained Transformer, a model that learns in two phases. First pre-training, then fine-tuning. Transformers are made of encoder-decoder modules. Encoder is used to encode words into vectors, which are a set of numbers. Decoder is used to decode vectors into words. Encoder-decoder are made of layers with self-attention heads. Attention helps the model decide what parts of input are important. Self-attention allows GPT to resolve context. Like in this sentence, it refers to the dog. The model learns these relationships. Each self-attention head takes your input tokens, represented as vectors, and transforms them into three versions: query Q, key K, and value V. These are learned linear projections. Then, for each token, it computes a similarity score between its query and all keys to figure out what to pay attention to. This is the actual formula. It multiplies Q and K to get attention scores, divides by a factor D to normalize, applies a softmax so they sum to 1, and then uses that to weight the values. This weighted sum becomes the output of the attention head, a context-aware representation of the input token. This is the overall transformer architecture. Pretty complex, right? Besides the core self-attention head, it also has other components, such as positional encoding for adding information about the position of each token, add and norm layers for adding the input back to the output of the attention layer, and feed-forward network, FFN, which are small multi-layer perception applied independently to each token. FFN introduces nonlinear transformations into the model. Think of attention as learning what to look at, and the FFN as learning how to process what it saw. Now you know the architecture core of ChatGPT, how ChatGPT answers a question. When you type a question, it gets tokenized, passed through the model, and outputs one token at a time until it's done. GPT works in two stages: training on supercomputers and inference, generating answers. Training happens once on huge GPUs over weeks. Inference, like what you use, runs the trained model to generate outputs. ChatGPT got much better through reinforcement learning from human feedback, RLHF, where humans rated answers, guiding the model to be more helpful and safe. What is RLHF? Large language models are first trained on massive internet text. They can generate fluent responses, but they're not aligned with what humans want. RLHF is a process to fix that. RLHF has three main stages. 1. Supervised fine-tuning, SFT. Train the model on examples of good behavior written by human annotators. This gives the model a head start in following instructions. 2. Reward modeling. Humans rank several model responses to a prompt. For example, good versus bad. A separate model is trained to predict the human's preference. It learns to score outputs. This is the reward model. 3. Reinforcement learning, PPO. The base model is fine-tuned using PPO, proximal policy optimization. The goal is to maximize the reward model's score, meaning respond in ways humans prefer. ChatGPT also has limitations. It can hallucinate, meaning it sometimes makes stuff up. It sounds confident even when it's wrong. ChatGPT is also limited by memory and context limits. It doesn't have memory by default. It only sees what's in the current conversation window, maybe a few thousand tokens. Since it was trained on human data, ChatGPT can also reflect human biases. OpenAI works to align it with safe and fair principles. What's next for ChatGPT? More memory, better reasoning, multimodal input, agents that act. ChatGPT will go far beyond text generation. Now you know how ChatGPT works under the hood. Try building with it, exploring its limits, or just asking better questions. Enjoyed this? Like, share, and subscribe for more clear and practical AI tech breakdowns.